values. Now when you graph a linear equation, what you're doing is you're drawing a line that represents the values that work for that equation. When you test a set of ordered pairs to see if they work, all you're doing is you substitute in the values for x and y and see whether the equation, see whether the two sides of the equation are equal. So just as an example here, we got if you have this as a problem here, determine whether each ordered pair is a solution of y is equal to 2x plus 1. All you're going to do is you're going to go ahead and just plug in this and see if it's true. Well, x is 0, so it's going to be, and y is 5, so it's going to be 5. Is that equal to 2 times 0 plus 1? Then we do the same thing over here. This is going to be 3, because that's the y, is equal to 2 times 1 plus 1. And same thing over here. Then we got 15. Is that equal to 2 times 7 plus 1? And when we do this, we see, well, this is going to be 2 times 0 is 0, plus 1, 5. So 5 is not equal to 1. So this is not a solution. For here, 2 times 1 is 2, plus 1 is 3. So yes, this one is a solution. Then we got over here, 2 times 7, 14, plus 1 is 15. So this is a solution also. So we got two solutions, and then we got one non-solution. So that's an important way of figuring that out. Now, if you look back here, the next part is when you are coming up with solutions, all you're doing is you're plugging in the values for x and seeing what value of y comes out for it. So if I'm asked to find 3 solutions for each equation, it doesn't matter what value of x I have. It's going to come up with the value of y. So I like to do this with just coming up with a table. So x plus 3 is going to be my y. And then y is what it's going to be. So here, if I plug in this and I say, oh, okay, well, you know what? Let me change this up and say, well, what's the value when x is, I always like to start off with 0. Let's start off with 0. When x is equal to 0, then it's going to be 0 plus 3. I like to draw a line across here. What's 0 plus 3? It's 3. So one point that works for this is 0, 3. So a second point that works, I just like to go on with 1. So now it's 1 plus 3. That's just going to be 4. So 1, 4 is a solution. And then one more after that, I'm just going to do 2. 2 plus 3. And that's 5. So these are all solutions here. And I could do this all day long for the rest of my life, and I'd come up with an infinite amount. Or I wouldn't be able to come up with all the solutions, but I would spend the rest of my days calculating this, and it would still not have all the solutions. So now, remember over here, if I do the same thing, x, 2x minus 3, and then y. And if I go back over here, I now am going to plug this over. So 0 again, I always like to use 0. So 2 times 0 minus 3. That's going to be just negative 3. So that's one solution. 0, negative 3. Next solution. 1. 2 times 1 minus 3. 2 times 1, 2 minus 3 is going to be negative 1. And you might notice here that there's a pattern that we went over before in the last chapter in terms of this sort of stuff here as to, well, since there's a 2x in front here, it goes up by 2 each time. The value of x goes up by 1. So this is going to be 2 times 2 minus 3. That's 4 minus 3, so it's just going to be 1. So another solution is going to be 2, 1. And that's it. That's all we're talking about doing. Now, the last part here is when you're graphing a linear equation. Now, it's very important that you get at least 3 points. And so we're just going to do what we did a second ago, which is just x plus 4, and y. This time we'll use blue for the actual part here. So x, it doesn't matter what you choose. Again, I just always choose 0. 0 plus 4. So the value of y is going to be there. So our ordered pair, our first ordered pair that we can put over here is 0, comma 4, because 0 is the value of x that we chose. 4 is what comes out in that equation. So 0, comma 4. So it's 0, 0 to the left or right, and 4 up. 1, 2, 3, 4. It's going to be our first point. And then you got 1, 1 plus 4. So then your value is going to be 5. So now we got one more solution. 1. So I got 1 over and 5 up. So it's going to be up here. And then I like to do, well, you should always do at least 3. You can do more if you want, but because without doing 3, you're not sure that you got everything the right way. Because what should happen is with a linear equation like this, that looks like this or looks like this, you should come up with a straight line. The only time when you don't come up with straight lines is when you have funky things like x squared in there. So it's going to be 2, then 6. You notice here, we got a nice straight line right from here. Well, a little bit off there, but you get the idea. A nice straight line right there. And that's what we're looking for. And obviously, we'd end up having the rest of it coming out, because that's what our line would look like. We'd connect it where the dots are. So same sort of exact thing here. All we're going to do is x, 3x minus 2, and then y. When I do that, x is 0. I got 3 times 0 minus 2. This is going to be minus 2. So one of the ordered pairs I'm going to use, 0 minus 2. 0 over minus 2 down. Now, we have 1, 3, 1, minus 2. So that's going to be 3, that term right there. Minus 2 is going to be 1. So it's going to be 1, 1 is our ordered pair. 1 over, 1 up. And so now we got 2, 3, 2, minus 2. And then 3 times 2 is 6, minus 2 is going to be 4. So we're going to have this ordered pair again, 2, 4. When we have that, we got 2 over, 1, 2 over, 1, 2, 3, 4 up. And then we have that nice line there that I'm going to try and draw a little bit better here. But you get the idea. It doesn't have to be perfect, but if you had a ruler, it would work even better. Now, important enough now, obviously this is something where I hope this doesn't happen to you, but this guy here, Professor Winters, is having problems. But I really wonder what would happen if he got the answer wrong. Hopefully nothing bad, because that guy does not look particularly charitable to mistakes. So make sure you know how to do this stuff, because you don't want to be Professor Winters if he gets it wrong.